Hello everyone, peace and salutations. I hope you are all having a good day. My presentation is on the impact of volcanic activity, more specifically on our oceans and our atmosphere and how it impacts climate change. So before I begin, I'm just gonna give some little apologies. I'm sorry. I don't have a Zoom account to do this on, so I have to record this on my phone. And yeah, so I'm gonna try to make it good so people can actually see what I'm talking about. And please forgive shuffling in the background. I gave myself little notes, but anyway, I'm just 47 seconds in, so let me just get started on my presentation. So let's see. So yes, impacts of volcanic activity by me, Afanime Idiong. Let's present. Okay. All right, so it just doesn't want to load, so we'll just push on. So the first thing I want to start with was this poem by Lord Byron, and I was seeing if you guys can guess what this is about before I tell you what this is about. So I'm going to read the poem, and then afterwards you can pause this video and then dissect it for what you think it means. So the poem goes: the bright sun was extinguished, and the stars did wander darkening in the eternal space, rayless and pathless, and the icy earth swung blind and blackening in the moonless air. Morn came, went, and came, and brought no day. So, pause this here. What do you think Lord Byron was talking about? It says full screen. Okay. So yes, what do you think Lord Byron was talking about? Technical difficulties, sorry. So yeah, or you could use that time to just, infer what you think he was talking about. So anyway, in 1815, Indonesian volcano Tambora spread more ash and gas than any other eruption in history. And Europe was hit by this, and this is what inspired this poem. So, and as hopefully through this presentation, you will learn how volcanic ash impacts climate change and our oceans, and how it's had an impact for a long time now. I'm seeing volcanoes have been around for a very long time, as we learned at the beginning of the semester. So, slide number 2. Ben Franklin and climate change. So in my study, it kind of alluded to Ben Franklin being among one of the first people to kind of notice how volcanoes impacted climate change, even though he didn't really know what's going on. So I wrote down in my notes. So in 1784, Benjamin Franklin is thought to be the first connection, thought to have made the first connection between volcanoes and global climate, while in Paris as the first American diplomat. So in the summer of 1783, he noticed that the climate was colder. The winter was more severe in Europe than what it usually was, and there was a fog over Europe. According to researchers, what Benjamin Franklin was supposedly observing was the result of a volcanic eruption. It was the volcanic eruption of the Lackey fixture system in Ireland. The Lackey event produced an ash cloud that reached into the stratosphere, causing the clouding in Europe. Also, researchers have used technology. Science is so cool, even though I don't ever really get the math. But they've used temperature data from 1783 to 1784, and there shows that there was an overall 1 degree Celsius decrease in temperature over the northern hemisphere during that period of time. The ash cloud was made up of sulfur dioxide, hydrogen chloride, and hydrogen fluoride gases. And during this time period, the gases combined with the water in the atmosphere, creating acid rain, which during this period destroyed crops and killed livestock in Ireland, but because Europe is close to Ireland, they also felt the effects of this. But this is alluding to something like just something bigger with volcanoes and our climate change. So next slide. So how does volcanic activity impact our oceans? So this is like a graphic that I found, but I'm gonna try to explain it to you because I know like most people, sometimes I don't get graphics, so I'm gonna try to do it a way that other people understand. So in my notes I wrote, eruptions eject particles and sulfur-rich gases into the stratosphere, as you can see from here. And the small ash particles decrease the amount of sunlight reaching the surface of the earth and lowers global average temperatures. And this is because ash from massive explosions quickly spread through the globe because the particles are so little that when they reach into the atmosphere, they're easily transferable from one place into the another. So another way this cooling is caused is because the sulfur in the atmosphere interacts with the radiation, with the light radiation coming from the sunlight. So some of those are absorbed in the atmosphere when it's coming towards the earth, but then others of it are reflected back into like space and the universe. I'm so sorry, that didn't make sense. But space, they're reflected back into space instead of being absorbed by the earth. So this clouding causes a cooling cooling of the earth's temperature because the sun isn't light can't penetrate the way it usually is, and it usually does, and therefore it cools our surface, which has an impact on our oceans. So again, like I said, wait, my notes. So, well, how does this impact our oceans? Well, the volcanic eruption. So when the volcanoes erupt, like we learned about Ireland and Benjamin Franklin, when the volcanoes erupt, they spew sulfuric acid into the air, which we know mixes with water and creates acid rain. But that's not the biggest part of it. What happens is because of this cooling that happens because of all these particles in the stratosphere and the stratosphere, troposphere, atmosphere, yes, because of what happens, it cools the earth. When the earth is more cooler, because there's not as much heat, evaporation doesn't happen, and because there's no evaporation, this means less rainfall. Because this means less rainfall, it kind of causes an imbalance in water influxes. So it causes an imbalance in the ocean. It lowers the ocean. It also lowers the ocean temperature, which can lead to densification, which then lowers sea levels. But then that's not all, ladies and gentlemen, because then I also discovered that another impacts from this is high latitude volcanic eruptions have the capacity to impact ocean circulation fronts, which we also learned about this semester. So when these eruptions trigger coolings, which shifts the planet's winds, so this kind of disrupts the planet's wind circulation. Wind currents like the northeastern and southeastern trade winds, which cools the earth and causes like El Nino kind of effects, which I think this is really cool. So from my research, it kind of said that like there wasn't a lot done yet on this, which is interesting because a lot of this stuff is simulated because you have to simulate a volcanic eruption. So through the simulations that have been run, they have kind of pieced together this little process that shows that like, yes, volcanoes do have an effect on climate change. Something else that I discovered that was interesting because, again, humans are the ones who are impacting climate change. Like the amount of carbon dioxide that we are pumping into our atmosphere is causing the excessive warming in our, within our, I don't know the word. If you know the greenhouse gas, if you understand the greenhouse gas effect, which I feel like at this point, you know, we should like the greenhouse. Anyway, I'm rambling. It's kind of the greenhouse gas effects that we are causing within Earth, which is like increasing our heating. But along my research, scientists think that you can use volcanic eruptions to kind of what is the word that I'm looking for, to combat that, which is interesting because it cools the earth. But if it's cooling and it impacts like water or water circulation and impacts like rainfall, then maybe not. But I just thought this was interesting. So this is a video, and I'm gonna try to hold it so you can watch. Oh, let's go back. Is it gonna play? Okay.
200 years ago, Tambora, a volcano in Indonesia, blew its top in the most violent eruption in recent history. Damage from the volcano and an associated tsunami was immense. Perhaps 100,000 people died immediately or starved in the aftermath. The effects on the wider world, though, were even greater. Like all large eruptions, Tambora's was to change the climate around much of the planet for years. But just how do volcanoes change the climate? Eruptions spew out not just lava and ash, but also gases. Indeed, it is these gases trapped under great pressure in molten rock that give an eruption its explosive power. For the climate, the key gas is sulfur dioxide. Once it gets into the stratosphere, sulfur dioxide from a volcano mingles with water, forming tiny sulfate particles. These particles reflect some sunlight back into space, and the surface below cools. They also absorb some sunlight, warming up the stratosphere. These temperature changes have big knock-on effects. A cooler surface means less evaporation, and thus less rainfall. A warmer stratosphere means stronger jet streams. In the year after Tambora's eruption, scientists estimate the stratosphere's sulfate veil caused a 3% drop in rainfall and cooled the planet by 1 degree Celsius. That is a temperature drop in 1 year twice as large as the long-term warming the Earth has seen over the past half-century. The climate upheaval caused a hiatus of the Indian monsoon, drought in southern Africa, and widespread crop failures in Europe, where it was known as the year without a summer. No one can say when an eruption large enough to have such drastic effects will happen next. That when will happen, though, is a certainty.
So I put that in there because I wanted people to actually like get a good explanation, and that was just like a short way of kind of like summing up everything I said in the previous slides. So on to slide number 5. So quick, can you, in your own words, describe how volcanoes impact our oceans? I hope you can, because if not, then that means I didn't do that well of, explaining. But hopefully, yeah. So in your own words, you can pause me here. Can you describe how volcanoes impact our oceans? All right, you've been paused. So furthermore, connection to oceanography and why I chose this topic. I was really interested by volcanoes. Was really interested by volcanoes. I think they're so cool. For there to be a system that creates that much energy, I just think it's really cool. I just really thought it was really cool. And at first I wanted to do something to talk about like how the lava kind of impacts the oceans, and what that does, but I kind of, when I was Googling volcanoes and impacts on our environment and the oceans, I saw like a recent study that literally came out like this month, and it kind of was connecting volcanic eruptions near like Indonesia and the Southeast Asian region in connection to tsunamis and rainfall that leads to like lack of rainfall that leads to like crop deaths. And I was like, oh, that's really interesting. So I decided to study that for this. And yeah, and I think that it's really cool because the ocean, like what we learned in this class is like the ocean really does have like a large effect and a large impact on our world, and something like volcanoes, because if you think about like volcanic eruptions, what is that supposed to do? It's only supposed to like spew sulfur into the atmosphere. Sulfur into the atmosphere. What would that cause? Acid rain, which I didn't really look further into it, but acid rain I'm sure that does have an impact on like ocean life, because if the water is coming back into the ocean and the ocean is digesting that sulfur dioxide, then there's definitely going to be impacts from that. And I think that we've learned that we've learned that in class too, with that cycle of like, oh, like what's in our atmosphere eventually comes down, and when it comes down, it has an impact on our animals. So I just thought it was interesting to see what that might look like. And so yeah, these are the questions. I hope you can answer them based off of the presentation. So the first is, what is the cooling effect? What chemical is spewed into the stratosphere after a volcanic explosion, or which chemicals are spewed, because I listed 3. And outside of the cooling effect, what other environmental problems are caused by volcanic explosions? And then these are my citations. Yeah, and that's it. Thank you all so much for watching my presentation. I hope you're all watching this safe, sound, healthy with your families. And yeah, enjoy the rest of your day or night whenever you watch this.